Hello everybody. Today we are going to do something a little bit different and a little more code focused. So what's happening today is we are going to use the Open-Computers mod with an wasm add-on, which allows us to run WebAssembly compiled code on our open computers. If you don't know what that means, basically for the purpose of this tutorial, we are going to be running code we wrote in Rust instead of Lua on our computers. You may be wondering, why not just use Lua? It's what's there. Why do you want to use Rust? Well, Lua frankly sucks. It's not type safe. There's no semicolons, which that's really not that big of a deal. But there's also not, like, the bracketing's really weird, but mainly the type safety is not there. So we can have a variable that is an integer, and then all of a sudden it becomes a string, and it's just hard to code in. So for today's tutorial, we're going to make this ear rape machine. And it sounds bad. I get that. You can make a lot cooler, more practical stuff with this, but that's just what we're going to do for the tutorial. So first off, obviously, you're going to need Minecraft Forge. To start out, you're going to want, obviously, to install the Open-Computers mod for 1.12, and then also go ahead and install the oc-wasm add-on, which is also 1.12. They're not updated. I wouldn't super expect them to get updated further, but it's cool as hell. So that's what we're going with. If you need to help installing Forge, this might not be the best video for you, as that is pretty easy to do, and we're going to get into like code and kind of confusing stuff later. But don't just like, oh no, I can't do this, and then just leave. Like, I would recommend trying to learn. But there are great videos out there. Just search how to install Forge, how to install mods, and you'll figure it out. You can kind of follow along and start learning to code. So the next thing we want to do is open yourself a terminal. I don't know how you do this in Windows, but in Linux, just open a terminal and install Rust with this command. This is the command you can find on Rust's website. And just go ahead and run that. I've already run it, and it's just going to download the installer. It gives you this whole, like, prefix stuff. Hey, we're about to install Rust. Just go ahead with the default installation to 1. I already have it installed. I'm going to cancel my installation, but just go with all the default options. You're not, like, probably going to need to customize it realistically. And then I'm also going to provide you with another file once that's done. And it is this script I wrote to install all the other dependencies we're going to need. But before you run the script, restart your computer after you install Rust. So step 1, install Rust. Step 2, restart your computer. Step 3, run the script I made you. You can look through it and be like, wow, it's not installing viruses. That's cool. All it's doing is installing some dependencies for building software, and then cloning some repositories that are needed, building them, because we're making a bunch of stuff from source. Basically, we're pulling the developer's code onto our local machine, and then building the app that it is, and then installing the app. So here we install the WebAssembly stuff, and then we install the Open-Computers wasm BIOS. And when you're done with all of that, it will pop out this packed.wasm file, which I also have right here. So now we're going to be at the same place. If you run this file on your desktop, it'll just put this on your desktop. So this packed.wasm will end up wherever you run the script. And one thing to note, as you're running this script, it will take a while. Like, you're downloading quite a bit of information, but then also building the repositories is going to take some time. So if it's been running for 20 minutes, that's probably normal. Like, this isn't this isn't quick like coffee break. The whole process may take around a half hour. Depends on how fast your computer is. If you have like a Threadripper, it'll probably do it in like a minute or 2. If you're on slightly older hardware, it could take longer than 20 minutes. I don't know. Just depends on what hardware you're using, but don't get concerned if it starts taking kind of a while, because it will. So now that we have this packed.wasm, what do we do next? Well, we go ahead and I'll close that. We launch our Minecraft Forge instance that has the Open-Computers mod as well as the Open-Computers wasm mod, that other one we're talking about. Go ahead and launch this Minecraft version. Obviously going to be 1.12. Once that goes and loads up, go ahead and create a world, and then I will catch you inside the world. Alright, so now we're in our Minecraft world, and we need some items. You won't have this tab, don't worry about that, or possibly that tab. We just need to go to the Open Computers tab. We need to get ourselves a creative computer case. Obviously, you could do this in survival. Just would not really recommend it. At least for testing. Like, go ahead and do it in survival later. But so things we're gonna need is a computer case, a keyboard, accelerated processing unit, APU. You could also do this with a CPU and then also have a GPU. It's just easier if we use an APU, which is like a GPU and CPU combined. Hard drive, and then we need to find the OpenOS floppy disk. And that should be everything we need, but we also need a screen. One thing I forgot is we're going to need an EEPROM of Lua BIOS. And then, whoopsies. And then later we will also need another EEPROM. So might as well grab that now. You can just grab a blank one. So we have this computer. Go ahead, turn it on. And it will launch into OpenOS. So if we run the command mount, we can see that OpenOS is installed there, right here, on these read-only drives, OpenOS. So we can just go install, and then hit enter, and it will go ahead and install OpenOS on this computer. So just installing the operating system. While that is going, go ahead in here and take a look at what the UID of this hard drive is. So ours starts with the letter 15FB63, yada, yada, yada. So once this is done installing, because I don't really want to pause it in the middle. Cool, installation complete. We'll go ahead and reboot now. Sweet, so that works. So now head on over to your resource packs folder. It's the easiest way to get to your Minecraft folder. Go into your saves, into the world you're using, Open Computers folder, and now we remember those letters from before, and if you don't, just take a look, 15FB. So right here, so this is the physical, this is the file system on my computer representing the file system right here, because if we go cd to the home directory, all these files are, whoopsies, all of these files, it's the exact same thing. So now we go ahead and exit the world. So that packed.wasm that you made earlier, go ahead and copy that into the hard drive of that computer. Now when we go ahead and launch this again, so just gonna change out our monitor for a tier higher so it looks nicer. If we go onto the home directory, or not home, but root directory, and the list, we can now see that the packed.wasm file that we just put in there, this one right here, is right there. So now what we're going to want to do is making sure we have the extra EEPROM just handy, just have it somewhere around. We want to go and we want to flash this pack.wasm. And just enter. It will says insert the EEPROM that you want. We're gonna no need to overwrite our Lua one. We might want it for something else. And so we're like, yep, that's good. We hit Y to confirm. Tells us not to power down. And we need a label. So let's just call this like wasm-BIOS. All done. Sweet. So now we come in here. And the name, well, it's in here, by the way, in this upper slot, will not have changed. It only changes once you go and bring it into your inventory. That threw me for a loop the first time I did it. I was like, oh no, it didn't work. It actually did work. Yeah, so now we have this wasm BIOS. Honestly, we can leave it there because we're just going to reuse all these hardware parts. We won't need the OpenOS anymore. So we have a computer capable of running WebAssembly code, but we don't actually have any WebAssembly code for it to, execute. So go into your, actually I'll just go here, desktop, no, documents, Rust, open terminal. So you're going to need to run this command. It's a curl command, so basically it goes out and gets a URL. And it'll be like, oh, downloading wasm pack. And for me, it says already has the installation found. Do you want to overwrite this? I'm not going to overwrite it just because that feels like something could go wrong. But it's not going to say that for you because you've never installed this. So go ahead, go with the installation. Just if there's any options after that, just go with the default option. You'll be fine. But now that gives us access to the command wasm-pack. Whoopsies. Typing with one hand is hard. wasm-pack. So we can do it, run that command. It shows us all the options, and it even does it with emojis because I guess it's new and fancy like that. But all we're going to do, wasm-pack, new, and I'm just going to call mine tutorial, I guess. The actual naming does not matter. It's whatever you want to do. One thing to note, for Rust language, default like convention for how you name stuff is everything is lowercase and you separate words by like dashes or underscores. With that, if you don't do that, literally no one will care. Well, some people will care, but my guess is you're not like showing this code to the world. Okay, so now in that directory, we see the wasm tutorial, which I just created. Actually, we could have done that in terminal. So we're still in terminal. Go ahead and write /code wasm tutorial. That will open the folder in VS Code if you're using that. Otherwise, you can just right-click, open with other application, and select the application you want to open it in. But I think it's kind of fun to type the command code in this, and you sound all hacker man. All right. So first thing we want to do is go into the cargo.toml file. This is where dependencies are held, and as you can see, there's already a bunch of fancy stuff here. But we want to copy some more over. These are all the ones that they, let's say recommend, like they give to you already. So it's the wasm-bindgen, the opencomputers safe library, and the opencomputers just general computer functions that they've started building up for you to go ahead and use. There are some unsafe ones in counterpart to the safe one. That just sounds like a lot of work to figure out how to use. So I haven't done it. You could do it if that's what you're into. But we have these dependencies, and we can see they're all up to date, so we're chillin'. And if you're wondering what, nope, wrong one, extensions, what Rust, I'm using the Rust and Friends extension for VS Code. It has a bunch of different things going on for it. But one of the bits is that it will help a lot with dependencies. So you can make sure they're up to date. Kind of cool. So go into the SRC tab, which stands for like source. Or no, what does it stand for? Is it source? I'm not sure. And go into the lib.rs. We don't need literally any of this. Boop. Oh no, it's all gone. Let's cry. So that's all gone. I have some code I have already written before, so I'm just going to use that. You guys can use whatever the heck you want. It don't matter. But the main thing is that you need this hashtag no-mangle, which is kind of like annotations if you're used to Java. More or less an annotation. A public external C function. Run. It needs that, like that stuff all has to be there. So literally this line has to, no, actually these two lines have to be there. That is the entry point from the opencomputers mod into your Rust code. What you write in here doesn't really matter too much. It is important to note that there are some timeout stuff that you should look into. If your code takes too long to execute, it will time out. So like when I hit this loop, it times out because it just loops there. This is synonymous with a while true loop. It literally just hits that loop and stays there. It would stay in this loop indefinitely unless you return out of it, with like a return. Unless I went like that, it would stay here forever. And which is what I want, actually. Although it does actually time out the computer. The open computer, mind you. So, what I have going here is I have a beep parameter. So basically, it's going to make the computer beep. We're just going to make a new beep. It's what you can think of it as. And then the duration, we just have set to 1. millisecond, I believe they're all in. It actually doesn't say. It's just short, I guess. So anyways, I have it set to 1, just nice and a short time. The frequency changes every time we go through the loop for maximum ear rape. And then we tell the computer to beep at this set frequency, which is defined right here, and this set duration, defined right here. And then we go ahead and we take x equals x plus 1, which we start out as 100, and this is the frequency. So the frequency just scales up every time we hit the loop. So that's pretty cool. With the key in Visual Studio Code, go Control tilde, and that will open the terminal. Now we can go back, run the command wasm-pack, whoopsies, build. And this will go ahead and build all this juicy code we just wrote. We're hacking the world, dudes. It's amazing. So make sure, no, we do have it. Make sure you have that folder open again of the hard drive you're wanting to use in the OpenComputers mod. Grab that folder, go ahead and exit the world because we have to reload the world every time we add new files to this. When the building is done of your program, go ahead into the package folder and we can open containing folder. This wasm, go ahead and rename that to init, so initialize. You can go ahead and cut that, whoopsies, that's not what we want. Or no, it is what we want. I'm trying to go here. So you go ahead and cut that and then paste it into your folder of your Minecraft hard drive. Then in Minecraft, we can go ahead and open the world again. Go ahead and shift click this, and you can see it cycles through different versions of Lua. We want to make sure the architecture is on WebAssembly. And we have the wasm BIOS installed. And this now will go ahead and run whatever is named as init.wasm right here. And just like that, dudes, we got ear rape in a game. Who wouldn't want that? And you can see it gets mad, it times out. It's like, why am I stuck in a loop indefinitely? It doesn't like that. Like, okay, whatever. But I like that. I think that's sick as heck. So I think you can get rid of all of these. I'm not sure, except obviously this. Which actually I would like to test that because I don't know. Let's give it a test. I mean, it already works. So now we try and break it. All of this. Let's see if it still works. It works like a charm. It actually worked faster. Yeah, so go ahead and get rid of all that bloat in the folder. All you need on the hard drive is the init.wasm. And so now we can write code in Rust for OpenComputers, which is obviously very type safe. If you try and change a type in Rust, like, you're just out of your mind. Like, that's not going to happen. Before someone tells me you can, like, cast types, that's not what I'm talking about. I'm saying your string is not going to just arbitrarily become a number and you don't know why. That is the most annoying stuff I've ever had to work with when trying to write Lua programs. If that was sufficiently confusing, go ahead and drop a like. I just think that's way too cool. And obviously, this is showing, like, just the surface. Like, we're making noise. But we could do so much. There's so much cool stuff you can do just writing with real languages. So, that is all for today. There is links to all the commands I ran down in the description. Well, most of the commands. Here's the step-by-step that I designed for myself. I'm going to put that in the description. I'm going to put this chunk of code in the description and the dependencies you need in the description. That's all, boys. Until next time, I shall see you later. Bye.